Hey everyone, I'm Anish and welcome back to PrepFusion. So today we'll be starting the lecture 3 of linear algebra. So previously we stopped in between before the simultaneous operation on matrix. Also I gave you homeworks of few questions. So first we'll solve those questions, then we'll complete this topic and then we'll do questions on determinants. Okay, so basically using this simultaneous operations, and you will see finding the determinant will be much easier with the help of this simultaneous operations, where basically, what do we mean by simultaneous operations? Here, determinant should remain constant. Determinant shall not change. Okay. So yeah, let's start with the questions basically. So yeah, this was the question. So here, what do you have to do? You have to find the value of a, b, x, and y. So basically, it is given that a and b are equal matrices. So if a and b are, let me check if there are more questions. No, if a and okay, one thing I forgot to tell you is that I forgot to tell you the definition of a submatrix in the previous lecture. So I will just go through this again. A matrix obtained by deleting sum of the rows and slash or columns of a matrix is said to be a submatrix of the given matrix. Okay, you have to delete some of the rows and or columns of that particular matrix, then only you will get a submatrix. So here 8 7, like, is this like after deleting the rows and the columns, is this the matrix that we get 7 8, but here it is telling we're getting 8 7. No, that's why this is not a submatrix. Here 0 is not even in the this matrix, so obviously it is not a submatrix. Here 1 2 4 5, so 1 2 4 5 I am deleting this last column and this last row, so I get 1 2 4 5. Fine. Now this 2 3 5 6, I'm deleting this first row and this last column, so I'm getting 2 3 5 6 4 5. I'm deleting this first row, last column, and the last row. Okay, so I'm remained with 4 5. So this is the definition of a submatrix. Okay, so I hope you got the point. A matrix obtained by deleting some of the rows or slash columns of a matrix is said to be a submatrix of the given matrix. Okay, so I forgot to write the definition in the previous lecture. So yeah, this was one thing I wanted to tell. Now let's solve this question. If A and B are equal matrix, you have to find the value of x, y, and z. So basically A and B are equal matrix, that means both of them are same. So basically from here, what I can write? From here I can write, just hold on a second, let me put this towards the back. Okay, yeah, now it's fine. Everything is fine, right? Just have to check sometimes if it is recording or not. Yeah, now basically then what I can do is, let me take this. Basically if A and B are equal, right? If A and B are equal, then this will be equals to this, this will be equals to this. Okay, this will be equals to this, and this will be equals to this. Okay, so minus 1 equals to a plus b and 2 equals to a minus b. Simple simultaneous equations. 2 equals to 1, so a will be equals to 1 by 2. Now b will be equals to minus 3 by 2. Okay, b will be equals to minus 3 by 2. Now what about x and y? So this was the first thing. Let's solve for the second thing. X minus y equals to 2 and x plus y equals to 1. So again 2x equals to 3, x equals to 3 by 2, and hence y will be equals to what? Y will be equals to simply 1 by, not 1 by 2, minus 1 by 2 this time. Okay, y will be equals to minus 1 by 2. Yeah, so this will be my x and y. So yeah, these are pretty simple and basic only. So let's go to the next question. So here, if A is a singular matrix, then find the value of x. Simple, like I told you the definition of a singular matrix. The determinant of that matrix should be 0 if it is a singular matrix. So basically you find the determinant of this. Okay, determinant of this will be, so singular matrix means determinant of A equals to 0, hence okay. So like what you can do is, Okay, let's not do it right now because I haven't taught you simultaneous operations yet. Simply just you can open about this last column. So let's first mark this. Okay, plus minus plus minus plus minus plus minus plus. Okay, or you could have gone directly plus minus plus from here also, same thing. So I will open about the last column 2 times this 3 times 2 minus minus 2 times 2 minus x times this 1 minus minus 2 times 2, then plus 1 plus 1 1 times 2 minus 3 times 4, okay, which is equals to 0. So obviously we have to equate this with 0. What will you get? So what will you get is this will become 6 plus 4, so this is 2 times 10, okay, then minus x 1 plus 4, so this is 5x plus 2 minus 12, so this is basically minus 10 equals to 0. So your 5x will be equals to 10. Okay, so your 5x will be equals to 10. Let me just check everything is all right or not. Yeah, 2 times 2, this is all right. 5x will be equals to 10. I solved it actually and I've got x equals to 1. Just let me pause the video once. I will check and then I will come back. Yeah, sorry, I found out a mistake. Like it was somewhere around here only. I multiplied few wrong things over here. So this will be simply 1 times 2 actually, because I'm doing this right. I'm ignoring this and this. I'm taking 1 times 2 and minus 2 times 4. So 1 times 2 and minus 2 times 4. Okay. So so this will become like 2 plus 8, which is 10x only, and here, okay, this is 10x only, so this will be 10x. So that's why I was getting like 1, right? And I was thinking what mistake I'm making. So x will be equals to 1. Very simple. In later on, like this mistakes won't happen because we'll do simultaneous operations and we'll make more zeros, so that to compute the determinant it is much easier and faster. Okay, so next is this question: find the determinant of the following matrix. So you can directly find it. How? What you observe is this is a lower triangular matrix. Only lower L of the diagonal elements, all of them are present and other elements are not present. Okay, so this is like a lower triangular matrix. So simply what you can do is you can simply multiply this, right? You can simply multiply all these elements. So I won't solve with the longer method. Okay, lower triangular matrix, simply the determinant of A will be minus 3 into 2 into 5 into 1, which is minus 6 into 5, which is minus 30. Okay, so answer will be 30. You solve it using the lengthy method. Basically you break it down with the first row, so minus 3 into determinant of this, then 2 into determinant of this, into 5 into determinant of this, only 5, 1 only. So yeah, very simple. So you just multiply the diagonal elements. So yeah, that is it for this question. Now next question: if the determinant of matrix A is 10, then find the determinant of B. So here, what do you observe here? So I've told you one property, if you recall correctly. If you don't, I will again prove it in the next few lectures. So basically, when they are telling you determinant of this first matrix and they are asking for the determinant of next matrix, then definitely there is some relationship between the A and B. Can you observe that? What I observe is this first element is minus 2, this is 4. The second element is minus 4, this is 2. So in these two elements, what I am observing is basically minus 2 is getting multiplied. So my B equals to minus 2 times A, B matrix. Okay, so what will be my determinant? So my determinant, simply if you know the formula well and good, will be equals to 2 to the power this order, right? Order, which is 3 cross 3 in this case, 2 cube, and here not 2 only, we have minus 2 also. Don't neglect the negative sign this time. minus 2 whole cube into determinant of a. So if you don't if you don't know this formula, I've already derived it, or I will again derive it in this lecture also once, so you will again revisit this. So this will be simply minus 8 times the determinant of a, which is equals to 10. So my answer will be minus 80. Okay, this will be my answer to this question. So very simple. So yeah, don't forget the negative sign, very important, right? So yeah, let's now go come back to our actual topic, which is the simultaneous operation of matrices. So here you see three linear equations, right? So let me name this 1 2 3. Now like how do you find the solution? What do? You try to eliminate this x first, then you eliminate the y first, then you find z, then you put the value of z in this equation, then you eliminate some other variable, then do that, right? So basically what you should do, basically to find the solution, what I will do is I will basically subtract this 1. Okay, subtract this 1 from 3. So I will eliminate first, I will eliminate x. So what I can do is basically I can write my 1 as 1 minus 3. Okay, so what equation we'll get? We'll simply get this equation, right? Minus 2. Okay, so then simply I will get this I have to eliminate again this, right? So what I can do is I have to again eliminate this x. I can write my equation 2 as this. Equation 2 equals to this 3 times equation 3. Okay, not like this, this will be on that side. Two minus 3 times equation 3. Minus 2y and minus 5z. 3 times this, I'm subtracting 18, so this one minus 16. Okay, so you will get something like this. Then what you'll do, then obviously you will find y and z from these two equations, and then you will put this value of z here, and then you will find x and y from any of these two equations. So that is what we do in the matrices also. So if you check here in matrices, how will it look? So you write the coefficient matrix. Okay, obviously how to find the solution, right? Gauss elimination method, that is also another method. I will talk about that later on, but for now just in the coefficient matrix, what are we doing actually? Minus 2 3 1 minus 2 1 1. Okay, 1. So now basically did we do? We simply subtracted the first row with we simply subtract the first row from with the third row, right? So we subtracted this will become 0 minus 4 1. Okay, and this one was remaining here, and then we subtracted basically the second row with 3 times the third row. So in this operation, what did you do? We change our row 1 with row 1 minus row 3, and then in this operation what we will do, we change our row 2 with row 2 minus 3 row 3. This will become 0, this will become minus 2, this will become minus 5. So exactly what we have seen in this, right? In this, so this becomes minus 2, Okay, so this will be minus 2 and this will be minus 5. So exactly that is what is happening, and this one is becoming minus 4. This was already minus 4 and plus 1, whatever is here. So this is known as the simultaneous operation in matrices. Now what can we do, like which are allowed and which aren't allowed? What do you mean by that? So let's check this. Let's compare these two. So can you tell me, are the determinants of both the coefficient matrix same if I multiply just 3 with this? Okay, are they same over here? The answer will be no, they won't be same. Okay, what will be happen, what will happen in this case? What will happen in this case? Let's take an example. So if you just compute the determinant for both of these matrices, coefficient matrices, you will see it will get multiplied by 3, right? It will get multiplied by 3. So let's understand this case. So let's say I have a matrix, okay, which is a 2 cross 2 matrix. For better understanding, simpler example I am taking a12 and a22. Now I'm taking a B matrix, okay, which is almost same, but the second row is multiplied by a scalar of k. Scalar of k. So if it's multiplied by a scalar of k, like what is the determinant of a? Determinant of a is simply a11, a22 minus a12, a21, and determinant of v equals to this a11 times k a12 minus this, okay, sorry, a21 it should be, sorry, a22 it should be, sorry, into k a21. Okay, what can we observe? If we could take common a this k term, a22 minus a12 into a11, so determinant of v will be k times a. Okay, so determinant of v is k times a. So that is what is happening. If you multiply this with one row, right, this will be k times a. If you multiply with two rows, it will be k square. So yeah, so determinant will change. Determinant will change. So we can't simply multiply any row or column which is a scalar. Okay, that will change the determinant. We shouldn't do that. Okay, so here, what? Okay, are the determinants same over here? So what did I do? Okay, I made a mistake over here. I think, okay, this won't be 5. Some mistake has happened actually. Okay, how did it become 12? Everything got okay. Yeah. Can you check, are the determinants same over here? Can you check that? So if you check this, right, the determinant will be same over here. How? So what did we do in this operation? Can you tell me what did you do basically? Basically, we if I check this equation, what did we do? So here we have only z, right? So z is present minus y is present. So basically 2 times this, and we're adding this. Okay, this is already present over here. What? Okay, this is 4. Oh, basically I'm adding these two. Yeah, basically I'm adding all these 3. So what is this basically? What is this? So this equation, like, let me name this 1, 2 and 3. Okay, this equation is formed, third equation, like my row 3. Row 3 is formed basically from row 1 plus row 2 plus row 3. Okay, if you add these 3 equations, right, these 3 equations, you will get this equation. So this will become x plus 3x plus x equals to 5x minus 3, and this is plus 2, so minus y, and this one get cancelled, only plus z is remaining, and 4 plus 2 is 6, and 6 plus 6 is 12. So this is 12 only. Okay, so now let's just check whether determinants are same. If you check, right, if you check, so this is my A matrix, which is 1 minus 3 2 3 1 minus 2 1 1 1, and your B matrix, right, 1 3 5 minus 3 1 minus 1 2 minus 2, 2 minus 2 minus 1. Okay, so basically now here if you just calculate the compute the determinant, you will see that determinant of A equals to determinant of A. So this is a valid simultaneous operation. We can do this, we can do the addition, we can do the subtraction, all those things we can do just as we did in the elimination, but we can't simply multiply just a row with 3. Okay, we can't do that. So in this case the determinant will be same. Okay, what we did, we just added the rows. Okay, added the rows over here. Okay, so this is valid case. Okay, so like here, if in this case, right, if I want to write one more thing, B was equals to K times A, this means K is multiplied, K is multiplied with all the elements. K is multiplied with all the elements. So my determinant of B, I've already told you this, like you can do it with example also. Determinant of B will be K raised to power n determinant of A, which I've already solved a question on this, where n is the order of A or B, because both of them will be order, both of them will be same, because we're just equating that they are equal matrix, just with they are equated with a scalar. Okay, so order both of them will be same. So this is another important point to note. So what are my valid simultaneous operations? So what do you mean by valid simultaneous operations? Determinant should not change. Determinant should not change. Okay, so basically here A matrix, let's say A matrix is this. Okay, this coefficient matrix, let me copy this. This matrix. So you perform any operation like this, whatever operation you perform, it won't matter. Here you perform this simultaneously, right? You perform this simultaneously. That row 2 is changed to row 2 minus 3 row 1, which you already did over there, and we checked that determinant was same. Then like in the first case, right? In the first case, here you check it, here determinant will be same, determinant won't vary over here. Okay, like you are saying, but sir, here we multiplied by 3, the determinant got changed. Here we are just multiplying by 3 and leaving this as it is. That's why there what we're doing, which is multiplying by 3 and subtracting with this. Okay, and this we don't change, this we don't multiply with 3, we just multiply this 3 to subtract with the row 1. Okay, not to change this row 3. Okay, we just multiply with 3 the row 3 and then subtract with the row 1. Okay, so yeah, this is the case. And row 3, I can do anything, right? I can do anything. Row 3, basically row 3 minus row 1. The determinant, the new determinant and the old determinant, delta dash will be equal to delta. Determinant won't change. You can change the columns also, it doesn't matter. Okay, you can change the columns also. So simultaneously I'm doing this, like I'm simultaneously doing this. C2 is being changed to C2 minus C1. Okay, so I hope you understand, right? I'm multiplying 3 with this, then I'm subtracting with the I'm okay, row 2 is changed, so I'm multiplying 3 with this, then I'm subtracting with this. Okay, so to make a 0 over here, then I'm just subtracting row 1 with row 3. Okay, simply doing that. So basically what will this become? So let me write this. I will write this in next page so that you can understand this better. Let me write the resultant matrix over here. The resultant matrix will be minus 3 2. I'm multiplying 3 with this and then subtracting, right? So 3 times 1 is 3, which is getting subtracted, that is fine. 3 times minus 3 is minus 9, which is getting subtracted, it will become 10. 3 times 2 is 6 and it is getting subtracted, so it will become minus 8. Okay, then I'm just simply subtracting the row 3, I'm simply subtracting the row 1 from row 3. So this will be 0, this will be 4 and this will be minus 1. So yeah, this is basically you just check the determinant of this is, let me name this as a dash, okay, and they are same only, the determinant will be same only, okay, determinant will be same, determinant won't change over here, okay. So yeah, this is the first thing. Now let's like do it with the column operation. You just check for yourself the determinant. I won't do it for you. So what I'm trying to do, I'm trying to make zeros to compute the determinant much easier, like yeah, make it easier to compute the determinant. So what you can do, you can simply change your C2 with not C1, simply add this, right, simply add this plus 3C1, then C3 with C3 minus 2 C1, okay. So basically what will this become, so this will be simply 0, so I'm adding 3 times this, so this will be 10, 3 times this will be 4, and then I'm subtracting 2 times this will be 0 only, 2 times this will be minus 8 minus 1, okay. So yeah, it's almost the same thing only. So you check the determinant of this is, let's name this as a double dash delta, double dash will be equal to delta, okay. So the determinant won't change. So when will the determinant change? So now let's go for the third case. So in the third case, what we'll do is we'll try to manipulate the row and column at the same time. What will happen? So if I just copy this matrix, now what I'll do is basically I will change my C2 to C2 plus 3 C1 and this R2 to R2 minus 3 R1, okay. So let's see what happens over here. So initially let's compute the determinant. So if you compute the determinant of this A, right, A will be 22, computed it will be 22, okay. Now let's see what happens after we apply the simultaneous operation A triple dash. So basically C2, I'm updating the old things only with the help of old things. So C2 equals to C2 plus 3 C1. So this will give me this, I should, okay, this is 0, this is becoming I'm adding 3 times this, so this is becoming 10 and this is becoming 4, okay, and this is not changing anyways, 2 and 1, and this is 1 3 and 1. But in the same time what I'm doing is I'm also updating the row also. So if I am updating the row 2 R2 is becoming 3 minus row 1. Now this is the new one, I'm using the old one, so I will use the old one, not the new one, okay. So I'm doing simultaneous, right? This I haven't even gotten yet. This row 1 is I haven't gotten yet, new row 1. This is my old row 1 and that will be used here. So here row 2 minus, so this 3 minus 1 will be 2. Let me change this. 3 minus 1 will be 2, okay. Just hold on a second. Yeah, 3 minus 1 will be 2, okay. So I'm just using the old row 1 and row 2, okay, not the new one. So this will be simply 2, then 4, then minus 4. So let's compute the determinant for this. The determinant for this is 1 times 4 plus 16, then 0, then plus 2 times 8 minus 4. So it is 20 minus or plus 8, so it is 28. So like as you can see, right, we are getting confusion which one to take first, which one to not take first. So obviously we will not do this, we will not do this, not equal to this. So we will not apply row and column operations together. Also we will not apply simultaneous operations at once, okay. First we'll use one column and then we'll update the other column, we will not do them at the same time. So basically yeah, I have like I will tell you what to do and what not to do. So here what are the examples? So one example is which are valid and which are invalid. So I've already done them, right, I've already done them. So row 2 can be changed to row 2 plus 3 row 1, this is valid, okay. Now you can write row 3 can be simply changed to row 3 plus row 1 plus 3 row 3. This is also valid. We're not doing the together. We're not doing them together. Okay, we're not doing them together. Okay, so columns are also I have told that C3 can be equals to C2 plus C1 plus C3. Okay, this is also valid. Now which aren't valid here? Which aren't valid? So if we do one thing, C4 for C4, not for C4. So what I will do is I will change this row 3 to row 3 minus row 1, and then I will change my C3 to C3 minus C1. Okay, so this is not valid. This is not valid. So we shouldn't change the row and column together at once. Okay, we shouldn't do that. So generally just try to avoid the simultaneous multiple operations at a single stage. Just do them part by part, then it won't be an issue. It won't be an issue. Okay, so that is what I wanted to tell you. So here they have, like, the rules are, you can change any row ri my plus kij, where k can be any scalar. K can be any scalar. Okay, and the determinant will remain same. Here ci also will be equals to cj plus cj. Determinant will remain same, but don't perform them simultaneously. Okay, don't perform them simultaneously. That is what my recommendation will be. Don't perform them simultaneously. So do not use, that is what my recommendation is, row and slash column. Okay, for more than one operation in a single step. That is my recommendation. So this is my recommendation to you, else your determinant may change and your answer may change. Okay, so just while I am solving it, I will just use one operation, and that is simple only. Just use one step at a time. Either you change the row or you change the column. Don't do both of them together, or don't change two rows at a time. Okay, you can do that. Okay, but that's the same thing only. Just change one row, then you change the other row. Okay, so yeah. Also, don't use the row that has been changed already. Just at that moment. Okay. So there is another property of determinants, where if I have this like any determinant, right, and all the other elements are same, only with the first row, let's say a plus b plus c is added, so we can break this determinant into two parts. This is a property. So here what you can write is, this will be this one only. Okay, only this one, and this determinant will be only this one. Okay, so yeah, so you can break this down into two parts. We'll use some property and we'll understand. So yeah, basically let's start with a few questions, and from there we'll be able to grasp this concept, right? So this is the first question basically. So here we have to find the determinant of this. So how can you do this? So basically what you can do is, you can use just the property that we use now, or you can use a linearly independent property also. Okay, so we will see that. So here one thing we observe is, here this 8 plus 1 6 sorry 7 plus 1 5 plus 1 2 plus 1 and 1 plus 1 is the same thing as this, right? So we can rewrite this one. Now obviously seeing this is difficult for me also, it is difficult, so I don't use this. I will use the second method, but I will say you, right? So here let me color this. So this will be, this I can rewrite as 7 plus 1 5 plus 1 2 plus 1. Okay, the bottom row 1 plus 1. Now I will use that determinant property, just what I told you. So what I will do, I will break this down into two separate determinants. So obviously I will again paste this. Okay, so let me go to the next page actually. So this is my A basically. This is my A matrix. Okay, now determinant of A matrix will be, so this will be control, and then I can write this as the summation of two matrices. So just hold on a second. So this will be simply 7, 5, 2, 1, and this will be 1, 1, 1, and 1. So are you able to recall anything? Are you able to recall that if two rows or any two columns are same, or they are linearly dependent or scalar multiple, then the determinant will be 0. So here the determinant will be simply 0. Okay. So what is the other term now? So other term, what you can do, either you can subtract all this, right? Okay, you can subtract all this, so you will get 0 over here, and from there you can find the determinant easily. So basically what I want to tell you is, so basically what operations you will do, you will change your C2 to C2 minus C1, C3 to C3 minus C1, and C4 C4 minus C1. Okay, so basically what you will do, this is what you do. Just hold on a second. Put this camera correctly. Yeah. So everything is recording, right? Just hold on a second. Let me check. Yeah, this is recording. This is recording fine. So here, what you will do is, this will be 1, 7, 17, and 22. Okay. Let me make this smaller. And other elements, what will other elements become? So this will be minus 2. I'm just subtracting the columns. Minus 2. Then minus 4. Not 4, sorry. This will be plus 4. This will be minus 2. Okay, so this will also be plus 2 only. My bad. This will be plus 2. This will be plus 4. This will be minus 2. This will be 0 itself. Again, this will be minus 12. And this is minus 7, minus 5, and 0. This is 0 again. This is minus 6, minus 10, and this is minus 16. Okay, so now can you simply solve it? So if you simply solve it, what you will see is, let me just put this side over here. Let me color this with different things. Okay, simply you break about this row, then this will become one determinant of this thing, right? Minus 12, minus 12, minus 16. Now what do you observe here? Do you observe any pattern over here? If you observe, that's great. If you don't, then you have to solve it. So minus 2, minus 5, and minus 6. So here what you will observe is that if you like this slowly, after solving many determinants, this will automatically come into your brain. Okay, intuition will automatically kick in. So basically what you observe is, you try to make this minus 2. So how do you make this minus 2? You subtract row 1. You subtract from row 1 with row 2. So if you subtract row 1 from row 2, then this will be minus 2, and then this will be minus 5, and then this will be minus 6. So basically this is similar, this is equals to the row 3 itself. So basically row 3 and the linear combinations are like all the rows are linearly dependent. So they are linearly dependent. Obviously I told you, right, in short notes or key points, if rows are linearly dependent, then that means the determinant will become 0. So overall my answer will be that determinant of A will be 0. Okay, determinant A will be 0. So this is my answer. Now obviously if you don't use this property, I also generally don't tend to use this property. So just simply do the brute force approach. How? Basically method 2 is simply brute force. Simply find the determinant. Okay, just try to make as many number of zeros as possible in a single row or a single column. So let me copy the matrix. Simply use the simultaneous operations. Okay, so basically what I can do, I have to make, like, I will find where is my 1. Anywhere do I have 1 present? Yes, I have 1 present. If there isn't, so I have to make a 1. So 1 is present over here. I will use this 1 and make all this 0. All this 0. Okay. All this column 0. So basically what I will do, I will change row 1 to row 1 minus 6 row 3. I will change my row 2 to row 2 minus 7 row 3. And I will change my row 4 to row 4 minus to row 3. So this will be, so let's do this. So basically 6 row 3 I will subtract, so this will be 6 times, so 6 7 times 6 is 42. So 42 minus 22, so this will be minus 20. Then 630 minus 24, which is minus 6. Then 612, so this will be minus 2. This will be 0, this will be 0, this will be 1, this will be 0. Now let's do the second row. So this is 7 749 minus 17. So 49 minus 17, you can do like hand calculations, which is 32. So this will be 32. Okay, and minus 32 because 17 is on the in front. So minus 32. Okay, then this is 7 times this, so 35 minus 21, which is minus 14. Then 7 times this 14 minus 4, this is, okay, let me make a more space. And this is 7 5 2. And in the fourth column, what is happening? 2 times subtraction, right? So 14 8 minus 14, which is minus 6. Then 10 minus 6 minus 10, which is minus 4. Then 3 minus 4, which is minus 1. Okay, so can we observe any relationship over here? So yeah, relationship is everywhere. So let's just break it down further. So this will be, now this is basically what we can write is plus minus plus minus. Okay, so this is plus minus plus, okay, sorry, yeah, see, I was just about to make a mistake over here, minus. So this will be simply plus minus plus minus. So every adjacent row and column, it will change by plus, or like the sign will change. So here, like if you go in this direction, plus minus, then plus minus plus minus, then plus minus plus minus. So yeah, this is correct. So let me write 3 cross 3 determinant. So it will be 20 minus 6 minus 2 minus 32 minus 14 minus 4 minus 6 minus 4 and minus 1. So can we find a relationship over here? So if I multiply 2 with this one, okay, if I multiply 2 with this one and then add subtract with this one, then I will get this column row only. So my row 2 minus 2 row 3 is simply equals to my row 1 only. So like 2 times this is minus 12, so you subtract this, you will get minus 20, and similarly you will get minus 6 and you will get minus 2 over here. So again, they are linearly dependent, so you don't even have to do those fancy tricks and all those things, so you can directly find the answer, right? So they are linearly dependent. So if they are linearly dependent, okay, so if the linear dependent, definitely we can say the determinant of A will be 0. Okay, with the method 2 also you can say. Okay, so yeah, this was the answers for this question. Let's go to the next question. So in the next question, like determinant is given and the equation represents a line passing through which of the following points. Okay, so I should write this, the determinant of the matrix represents a line passing through which of the following points. So basically let's compute the determinant, and they're talking about some line, so let's see that. Okay, so if I see that, basically let's compute the determinant first. So what I will try to do is I will try to make more zeros right now. So I'll just copy this. Okay, I'll just, like, they here already, here is 1 0, I will just try to make this one also 0. So, or I can, what I can do here, I have seen x and y, so I will just use this one because here I don't have any x and y, so I'll use this row instead of this row. Okay, what I am talking about, I will make you understand. Just hold on a second. So I will explain, just hold on a second. This will be 2 1 0. So I will use this, what operation I will use? I will use row 3 minus row 2 instead of row 2 minus row 3, because for doing row 2 minus row 3, basically I have to use x and y. I don't want to use x and y. Okay, I will change row 3 instead. Okay, because x and y will stay in the same place. This will be y minus 1, x minus 2, and this will be 0. Okay, and this is simply plus minus plus minus plus. Okay, so now this determinant they have given us equals to 0, so we'll compute this. So this will be simply minus 1 times 2 times 0. Okay, wait, not 2 times 0, sorry, minus 1 times 2 times x minus 2 minus y minus 1 into 1. Okay, so let me use some other brackets. This is equals to 0, so negative sign doesn't matter over here. So basically y equals to 2x minus this is minus 2, this is minus 3. Okay, so y will be equals to 2x minus 3. Now you have to solve for this, so you have to put this each points over here and you check out that which points are satisfying following points. So basically now you put x equals to 1. If I put x equals to 1, what do I get? Y over here, x equals to 1, y is minus 1. So this first one is not satisfying. First one is not satisfying. It is telling me y equals to 1. No, here if I put x equals to 1, I get y equals to minus 1, which is correct. So this will be correct. If I put x equals to 2, what do I get? X equals to 2 means y equals to 1. Yes, this one is also correct, because this is telling me if I put x equals to 2, I will get y equals to 1. Okay, now if I put x equals to 2 again, it is telling me that I will get minus 1, which is not possible. With we can only get 1 point with a straight line, right? We can't get same point, so else it won't be continuous. So this is wrong. Okay, so our answer is B and C. Okay, so these type of question also come up. Just simple, you have to compute the determinant, and they have already given you the determinant. Just you have to find the relationship between the x and y, and from there you just put the points and you get the value. Or they may ask what is the slope of the line. Slope of this line is +2. Okay, anything else? What is the y-intercept? What is the x-intercept of the equation formed by the determinant? Anything they can ask. Okay, so yeah, it's very simple question only. Now let's come to the next question. Here you have to find the determinant of the matrix. Okay, again here what you can do, you can use that simple trick, or you don't have to, because here, no, we can't use that trick because that was for a single row or single column. Okay, here what you will do, what you can do is, I'm observing, right, I need to make these zeros. Okay, that is a first priority to find the determinants. Make as many zeros as possible. So I can do one thing, I can change all the rows, right? I can change row 2 to row 2 minus row 1, row 3 to row 3 minus row 1, row 4 to row 4 minus row 1. Okay, so this one 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 0 0 0, this one will become A, 0 0 0 0, B, 0 0, everything is 0 over here. So this is like a only. Okay, let me take this to the next page, actually, else this will be confusing. The first question, this is Okay, so this is like a upper triangular matrix, right? Upper triangular matrix. What is the determinant for upper triangular matrix? Simply it is a multiplication of the diagonal elements. So here determinant of A will be simply equals to, or delta I can write, 1 times A times B times C, which is ABC. Okay, let's solve the second question. So for second question, again your main priority should be to make number of like a high number of zeros. Okay, but here what else? For making zeros, another priority is try to make all like ones also, try to find ones also. So while computing determinant, what should be your aim? So I should write here, while computing determinant, and just hold on a second. Basically your first aim is make as many zeros as possible. So I should write this like this: make zeros in a single column slash row. And then second aim should be try to find slash make ones. Okay, in a same thing only, single column or row. So like in this case, what you can do is you can argue with me that here I am seeing A's, right? I can make zeros over here, I can make zeros over there. Yes, I will say you, yes, you can make zeros, like two of these elements I can make zero, but this will be non-zero. Okay, here also two of the elements I can make zero, but this will be non-zero, and like that also you can compute, no worries. But like, is there anything else we can do? One thing what I'm observing is, if I either add all the columns or add all the rows, okay, I'm getting something same, x plus 3a. Okay, now what I can do is I can take that common, because with determinants I can take either a common term from a row or a column, but with matrix all the elements should be present to take something common. What do I mean by that? So basically here with determinant, what I can do is, let's say I have a11, a12, a21 and a22, which we have already proven. So this, let's say this is k. So what I can write is, I can write it like this: I can take common k over here, okay, and this will be still a12, a21 and a22. Okay, so I can do this, but with matrix I won't be able to do it, right? Matrix, with matrix all the elements should be multiplied. Okay, I won't be able to take common. Okay, so I hope you understand the difference between these two. Okay, so this is a good thing you have to like understand. With either in column or row we can take common, right? So let me just increase this. So yeah, this is the thing. So now basically what you'll do, what I can do is what I'm observing, if I add all the columns with the first column, then what will happen? So what I'm trying to say is, let me change this. Okay, so what I will do, I will add C1, I will change C1 to C1 plus C2 plus C3 plus C4. So what will happen, basically, let me copy this. So basically, this will be x plus 3a, and all of them will be also x plus 3, and I'm also computing the determinant, not talking about the matrices. Okay, so what I can do next, I can simply take common x plus 3a. X plus 3a I can take common. Okay, so this will be 1 1 1 1, and this will be a x. Now I can make zeros, right? I can make 3 zeros. Previously I was able to make only 2 zeros. Now I can make 3 zeros. So that is why I wanted to do this. A. Okay, I can just simply copy this actually. So now what I can do, I can do this operations, right? So I can simply do, I change row 2 to row 1 minus like row 2 minus row 1, row 2 minus row 1. I can change row 3 to row 2, row 3 minus row 1. I can change row 4 to row 4 minus row 1. Okay, so this will be 1 0 0 0. This will be a, and I have to make more space because there will be some x minus a's. So this is x minus a, this is 0 0, this will be also 0, this will be x minus a, this will be also 0 0, this will be x minus a, and this will be 0. Okay, now this is like a upper triangular matrix. Okay, if you observe this carefully, this is a upper triangular matrix. Okay, UTM. This is upper triangular matrix. Okay, so basically this is upper triangular matrix. So this is upper triangular matrix. I can simply multiply the diagonal elements. So what will my determinant delta become? Delta will be x plus 3a is already present over here, and diagonal elements is x minus a into x minus a into x minus a. So this can be written, delta can be written as x plus 3a into x minus a whole cube. Okay, so simply like that is how you solve this simply. Else if you would have solved like that, okay, you would have gotten this in the expanded format and it would have been difficult. That's why sometimes you have to do it like this only, because in the options this will be only present. So yeah, it's sometimes difficult. I do understand that, because these sometimes you have to mug this one up, how to solve this type of question, right? So this is difficult, but that's how you do, right? With more practice this one will come with intuition more. Okay, so yeah, that is one thing. So let's solve for the third question. So for the third question, what do you see? So these are bit of trick questions which you have to do with bit of intuition. Okay, not just simply directly solving it. Okay, not just simply directly solving it. So here, okay, this is directly getting copied here. Let me delete this. What do I see? Can I make anything 0 over here, which is simply simultaneous operations? No, I can't. But can I make any ones over here? What I can do is, if I multiply this, okay, if I multiply this with a, this will become 1. If I multiply this with b, this will become 1, and if I multiply this with c, this will become 1. Okay, so like is it okay for us? Like can we do that actually? let's see. So if I multiply this with a, this will become 1 1 1, but individually can I multiply? I have to divide also, right? I have to divide also. So like what I am trying to say is, if I multiply this with a, okay, I want to multiply this with a, I want to multiply this with b, I want to multiply this with c. So individually row I can multiply, obviously I have to divide, because the determinant should remain change, else if I just simply multiply a row, the determinant will change. Okay, so what I will do is, I will multiply a times b times c, and then also I will divide by a times b times c, and then, okay, let me change this to determinant actually. Then this will be simply only the same thing only. Okay. So now what I will do, I will just keep them inside, I will just take them inside, right? If I take them inside, this will become, so this is 1 by b, so this will become 1, and this will become a square. I'm just multiplying a with the first row, a square abc, this will become 1 b square abc again, and this will become 1 c square abc. Okay, like what do we observe here? We, in the denominator we have a abc. Okay, 1 by abc is present obviously to make the determinant same, else the determinant will change. Now what can we can do? Either we can subtract, like make zeros, or we are seeing some simple thing, we can take common this abc. If you take common this abc, okay, if you take common this abc, what will happen? This abc will get cancelled out, but the two columns, the first column and the third column will be identical, so hence obviously c1 equals to c2 c3 linearly dependent, hence delta will be equals to 0 itself, okay. So basically from here also you can say that delta is 0. Okay, else you could have solved it in other like lengthy method also, no worries. So next is this one. So let me just take this. So simply what you can do here, either you can make zeros over here, right? Either you can make these two zeros, or again if you add the columns over here, if you add the columns, you will see that again you're getting the same thing all once, like 2a plus 1 plus 2a 1 plus 2a. Okay, or you can make zeros also. I'll solve using both methods, whichever is suitable for you. So first I will try to make zeros. So what I will do is, I will do this row 2 change to row 2 minus row 1, this row 3 change to row 3 minus row 1. Okay, so basically this will be 1 plus a1, and this will be 0 and 0. Okay, and I'm subtracting this, so this is a1 and this is a only, subtracting this, so this is minus 1 and this is minus a only. Okay, now you can do the simple, like as you can observe, right? If you take common a over here, these two rows are same only, so determinant would be 0. You can do this, or like how you can do, okay, or another method is like these are same things only, you can add all the columns. So your c3, you change your c3 to c2 plus c1 plus c3. Okay, so if you change it, so it will become something like this. This will be 1 plus 2a, this will be 1 plus 2a, this will be 1 plus 2a. Okay, now what you can do, you can simply like, is this 1, no, this will be 2 plus 2a, right? 2 plus 2a, sorry, 2 plus 2a. Okay, so again, right, if you take this common, okay, am I getting confused over here? Just hold on a second. Will this even help us do anything? This won't even help us. I'm sorry, what I was thinking. Just hold on a second. Yeah, okay. So what I meant to say was, like, if I take common 2 over here, will it even help us? Just thinking something. I have also forgotten like how to do this. That's why I tell you to do it with this method only. I've also forgotten what was the trick for this. So basically, yeah, I'm not able to recall right now. So yeah, you can see that determinant is 0. That's why I don't recommend this method, because I also sometimes get forgotten this method. So I'll try to figure this one out later and try to write this here. It's like I've forgotten what was the trick for this. Now let's come to the last question basically. So this question is basically on the formation of matrix. We've already done this previously, something with a diagonal matrix, I believe. Now let's do this with another question here. If A is a matrix 3 cross 3 matrix and Aij are its element, and B is a matrix 3 cross 3 matrix and Bij are its element, such that Bij is 3 to the power I plus j Aij, where I and j are basically row and column. So this is understandable. So for all I and j are row and columns. So this is understandable already. And determinant of A is given 1. So what will be the determinant of B? So how do we solve it? So basically, you have to first write the matrix. Then only you will be able to understand things. So what is my A matrix? So let me write my A matrix. A matrix will be, it is a 3 cross 3 matrix, right? It is a 3 cross 3 matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. So now what do? You basically write the B matrix now. So what is a B matrix? B matrix is same as this only, but with a twist, obviously. Make more space. So this will be simply 3 into I plus j. So in the here, what is my I is 1, j is 1. So 3 into 1 plus 1, which is 3 square. So this will be 3 square, and similarly this will be 3 cube, and this will also be 3 cube, and this will be 3 to the power 4. 1 plus 3 is 4. This will be 3 to the power 4, and this will be 3 to the power 4 also, and this will be 3 to the power 5. This will be 3 to the power 5, and this will be 3 to the power 6. Okay, so now what can we do? We can take common over here, right? We can take things common over here. We can take 3 square from here common. Okay, and okay, let me do one thing. Let me take it, yeah, 3 square, 3 cube, and 3 to the power 4 from each of these columns, right? So or you can take from rows also, 3 square, 3 cube, and 3 to the power 4. You can take from rows, whatever is suitable for you. You take common from each row. I'm taking common 3 square, then 3 cube, then 3 to the power 4. Okay, so this one will become A11, and this is this will still remain something. Just hold on a second. I'll just copy all these elements actually. Let me reduce the size a bit. Just hold on a second. Let me place this here. Let me delete this. Okay, so I have taken common 3 square over here. So this will be only 3 to the power 1. This will be 3 square. This will be 3 square. I have taken 3 cube from here common. So this will be 3 and 3 square. This will be 3 and 3 square. Again, what I can do is I can take common from each of the columns. So here I can take common 3, and here I can take 3 square common. So let me go to the next page. So I should copy this whole thing. Okay, this is actually not matrix. This is determinant, right? This is determinant now. So determinant of B I should write, else you will get confused. And obviously, as I told, right, I'm taking common 3 from this column and 3 square from this column. So this is 3 into 3 square, and this is what, this is the A matrix itself. This is the determinant of A matrix, which is equals to my determinant of B matrix. So this is equals to determinant of B equals to 3 raised to power, how many, how much is this? So 5 4 9, no sorry, 5 9 10 12, 3 raised to power 12, okay, into determinant of A, which is equals to 1 itself. So my answer is 3 raised to power 12. So let me just calculate. Hold on a second. Let me just calculate what is 3 raised to power 12. Or most probably in the options they will give you like only 3 raised to power 12 only. 3 raised to power 12, 3 raised to power 11, something like this. This will be written in the options, or F else it is numerically there. The numerically the answer will be 5 3 1 4 4. Okay, 5 3 1 4 4. So yeah, this is the answer for this question, and this is the end of this question. So like, I hope you got all the points. Like, these are simple. This you have done, class 11 12. So you could have watched this in 2x, because like these are basics for the diploma students. They need to watch more slowly. They need to do operations more carefully, because that may mess up with the determinant. So you just check which operation are valid and not valid. I've already explained you everything with examples, proper examples, all those things I have explained. Okay, so what things you should keep in mind while computing the determinant, I also told you, right? Try to make zeros, try to make ones. Those are important things. Okay, so yeah, I hope you got the points and all those things. So yeah, in the next lecture we'll study about the inverse of a matrix, and then do questions on that, and then we'll move on with other topics. So yeah, I hope you like this lecture. If you did, do hit the like button, or there isn't any like button, because if you're watching the app. So just tell me if you like this lecture, and if you have any more doubts, you can ask in our doubt group or in our Telegram group. So yeah, thank you for watching, and I will see you in the next video.